Hello and welcome to a nostalgic math chat. Today we're starting to look at IEB's paper 2 from November 2023. And yeah, let's get into it. We're looking at question 2. And here's what's going on. In the diagram, ABCD is a trapezium with AD parallel to BC. Kind of comes with the turf of a trapezium, two sides. We know that two opposite sides, there's one pair, at least one pair of opposite sides that are parallel. And we're told that BCD is 90 degrees, so CED is perpendicular to BC. Right, and then the points A41, B04, and C67 are given. E is a point on CA, so that EC is equal to EA, so E is the midpoint of AC. Right, first thing you asked is to determine the gradient of BC. Okay, so that's very straightforward, right? That's kind of grade 9, grade 10. Given 2 points on a line, to work out the gradient, you just use the gradient formula, yeah? So the gradient, I don't know if I'm going to make it in here. There's such little space. Let me just move this down so that I feel less pressure. Right, so the gradient of BC will be, let's say, 7 minus 4 over 6 minus 0. You can work that out on your calculator. You'll find that the answer should be a half. And even if you started with the B points and subtracted the C, not the B points, the B coordinates, and subtracted the C coordinates, you should still get an answer of a half. Also, our line looks like it has a positive gradient, so kind of helps when you then get a positive number. That's kind of another sanity check you can do. Right, then you're asked to determine the equation of the line CD. CD, so this guy, okay. So we just have 1 point on that line, but we can use the fact that these two lines are perpendicular to figure out the gradient of CD, because we now have the gradient of BC. So we know that the gradient of CD will be the negated reciprocal of this guy. So it'll be a negative number and 2 over 1, which is just the same as 2. So the gradient of CD is negative 2, and then we can use this point to figure out the C in y is equal to mx plus c. So we know that m is negative 2, okay, and so we can sub in the point C. So then we have 7 is equal to negative 2 times 6 plus c. So 7 is equal to negative 12 plus c, and so c will be 7 plus 12, which is 19. So the equation of CD is y is equal to negative 2x plus 19. Okay, let me just double check with the memo as we go, so that if I make a big mistake, I can catch myself sooner rather than later. So question 2, A1 gradient is a half, and question 2, y is equal to negative 2x plus 19. Lovely. Next question says, determine the equation of AD. Okay, so AD is this guy, and hence the coordinates of D. Okay, so there's two things happening here. First, we need to find the equation of AD, and we can again use, so here we use the fact that these two are perpendicular to find the equation of this line. For AD, we can use the fact that these two lines are parallel, which will give us information about the gradient of AD. So let's do a different color. So the gradient of AD is equal to the gradient of BC, because they're parallel, and that's half. So therefore, y is equal to a half x plus c, and then we can sub in the point we've been given on the line, which is A. So my y is 1, my x is 4, so 1 is equal to 2 plus c, and therefore c will be -1. Alright, so the equation of the line is, the line AD is y is equal to 1/2x minus 1. And then the way that we can find the coordinates of D is by using the fact that D lies on this line and lies on this line. So we need to find the point of intersection between the two lines. So we're going to say, to find D, we're going to say, okay, when will this expression equal to this expression? And we have 5 over 2x on this side if I add 2x on both sides. And here we'll have 19 plus 1, which is 20. So then x will be 20 divided by 5 over 2, which is, I need to find 2/5 of 20. I think that's 8. Yeah, right. So we know that the x coordinate is 8, and then the y coordinate of D will be, you could put it into either. That gives me 3. And if I put it in here, I get -2 times 8, which is -16, plus 19 also gives me 3. So, right, so therefore the coordinates of D are 8 and 3. So let's see. We have y is equal to 1/2x minus 1 as our equation, and coordinates of D is 8 and 3. Awesome. Okay, so just going to quickly transplant that information to here. So this, we just know the gradient is 2, but we can also easily see the equation because they've given us the y-intercept for that line. And then we have y is equal to -2x plus 19. And this is y is equal to 1/2. Okay, this is not working out for me. I'm just going to write it nice and big over here, away from the picture. Y is equal to -2x plus 19. It's the first one. Y is equal to 1/2x minus 1 is the next one. Okay, and then I would like to rotate it. That's our first one there, and then this one. Make it slightly smaller. Okay, right, and then we also found out the coordinates of D are 8 and 3. Okay, cool. So the next question says, it is further given that point F, this guy is a point in the first quadrant, okay, so that FEDA is a parallelogram. And remember that this order matters. That tells you the direction of, or the relationship, or the sequence of the vertices of the parallelogram. So FEDA. So it wouldn't, if they had said EDFA, for example, then the parallelogram would have been something like EDFAF. Oh my goodness, A. Oh, that's a terrible one. Okay, no, let's try that again. If it had been EDFA, then it would have been EDFA. Yeah, then your F would have been here, for example. Or if it had been EFDA, then it would have been something like EFDA. A, like that. Then your F would have been up here. So all this to say, the order of those letters is very important in the drawing of your parallelogram. Right, okay, and I mean, you don't even have to figure out where F is because they've kind of indicated it for you on the diagram. Okay, right, so FEDA is a parallelogram. The coordinates of D are also given now, which they confirm to be 8 and 3. Then you're asked to determine the coordinates of F. Right, so there are a couple of ways that you can do this, right? I think that the most straightforward is to just count manually. So to use the fact that in a parallelogram, the opposite sides are parallel, first of all, so they have the same gradient. And second of all, they are equal in length. So if I can figure out, for example, the gradient of ED, and not only that, if I can figure out how much, say, from D I need to rise and run, then I know that from A I need to rise and run by the same amount. And that is because, first of all, the gradients are the same, right? So the rise over run ratio will be the same for both of these lines. And secondly, they are the same length. So it's not only that the ratios are the same, but it's that the rise and the runs are also exactly the same. Right, and yeah, so you could do it with E, looking at the relationship between E and D and copying it for A and F, or you could do it for the other sides. You could look at the relationship between A and D, right, and then copy it for, well, okay, you'd have to look at it backwards. Not have to, but easier to look at it backwards, so that you can say, okay, from D to A, I went down this many steps and across this many steps. So from E to F, I'm going to go down this many steps and go across that way to get to F. And I think because, well, either way, we're going to need to work out the coordinates of E. So let's do that first. So we're going to use the fact that E is the midpoint of AC. They gave that to us in the first part of the question. So E, the coordinates of E will be E. The average between C and A's X coordinates, and the average between C and A's Y coordinates. So that is 10 over 2 and 8 over 2, which gives us 5 and 4. Okay, so now I'm going to look at how many steps do I need to go from D to A. So from D, I need to go down, so from 3 to 1, so that's going down by 2 steps. And then from 8 to 4, I'm going backwards 4 steps. So I'm going to do the same from E to F. So the coordinates of F will be 5. We're going to need to go backwards 4 steps on the X. Oh, why am I still in fraction mode? So from 5, we're going to go back 4 steps. And from the Y coordinate 4, we're going to go down 2 steps. And maybe let me do it like this so that it's, and maybe I'll, not too much work. Ooh, 5 minus 4 and 4 minus 2. Right, and that will be the F coordinates will therefore be 1 and 2, right? Another way that you could have done this, of course, is to figure out the equation of EF, figure out the equation of AF, and find the point of intersection. Could you even do that? Yeah, you could, because then you could do that by finding the equation of ED, use the fact that they're parallel to then find the equation of AF. But yeah, that would be a very long time. Yeah, okay, so let's just make sure we got the right answer then. Yes, so we get F as 1 over 1 and 2 Do we get different midpoints? Oh, hectic. Wow, they use such an interesting method. I'm not sure I entirely follow it. So they found the coordinates of E, fine, the way that we found them. Then they find the midpoint of AE. So I'm just going to rub this out so that I can see more clearly. The midpoint of AE, okay, so let's say somewhere over there, they find that out. And then they say the coordinates of F will be x plus 8. Oh, okay, so then they look at this line. Okay, to say we know that this midpoint is also the midpoint of DF. So if we know what that is, then we can figure out what that is. Okay, so there's another way that you can approach the question as well. Okay, right, then the next question says, determine the size of the angle EAD. Okay, so we're looking at this angle over here. Ooh, precision. Okay, yeah, I think I'm writing somewhere and I'm actually not. Wow, this is really actually quite off of me. Anyway, so that angle, let me not jinx it by trying again. Correct to 1 decimal place. Okay, so how can I find that angle? So I am inclined to use the cosine rule. So if I can find that length, because I know the coordinates of E and A, I know the coordinates of E and D, I know the coordinates of A and D. So if I can find all those lengths, I can use the cosine rule to find the size of EAD. Okay, so let's do that. Oh, okay, whatever. So start out with EA is equal to the square root of, so E is 5 and 4. Okay, so it'll be 5 minus 4 squared plus, yo, I knew my bad handwriting was going to come back to bite me in the butt. Okay, and that is 1 plus 9, so that is the square root of 10. And then AD is the square root of, so that will be 8 minus 4 squared plus 3 minus 1 squared. So that's 16 plus 4, so that's the square root of 20. I'm just going to keep it like that. Yeah, instead of, turning it into that, because I don't think there really is a purpose for that at this point. Leave that kind of stuff for like right at the end, generally. And then ED will be the square root of 8 minus 5 squared plus 3 minus 4 squared, which will be 9 plus 1, so that's also the square root of 10. Okay, so an isosceles triangle. Lovely. Yeah, okay. So I'm also just gonna move this guy maybe onto the next page. So then with the cosine rule, this side we can call A, this side we can call D, and this side we can call E. So the cosine rule tells us that cos of angle A, in this case we're referring to angle EAD, will be equal to D squared plus E squared minus Okay, so this is a squared is equal to the 2de cos a. Right, I was thinking, where does the a come from? Okay, right, yes. So if, and we know that we want the a, so I'm just going to rearrange the equation now before we sub in values, so that by the time we get to the values, we've already dealt with the making the unknown the subject of the formula. So that'll be, we can then just say, okay, these minuses become pluses, and a squared will be the only negative term. And over here, we're just left with cos a. Okay, right. Need to move this guy down again. Okay, so now we can say, so this guy over here, EA is D, AD is E, ED is A, right? Let's double check that. EA is D, yes. AD is E, and ED is A, yes. Okay, right, so we can now put those values in. So we've got root 10 squared plus root 20 squared minus root 10 squared divided by minus 2 root 10 root 20 is equal to cos A. Okay, so that want to simplify first before I take it to the calculator. So that'll be 10 plus 20 minus 10, and down here we'll have minus 10, minus 2, and root 200, which is the same as 20 over minus 2, and that is 10 times root 2, right? Because root 200 is the same as root 100 times root 2. Don't mind this one being outside. Right, and that just becomes a 10. Okay. And if we simplify that even further, then minus 2 times 10 is the same as 20, so we just have a 1 and a 1 there. So we end up with negative 1 over root 2. Oh, hectic, but this is like special angle stuff. Okay, is equal to cos A, right? And we know that because we're dealing with a triangle, right? That means we're only looking at angles that are quadrant 1 angles or quadrant 2 angles. So where is cos negative? If we think about cos is negative over here and over here, and these angles are not angles we're considering. We can't have angles bigger than 180 in a triangle. So we're only going to consider this angle, right? So cos, not cos. So we're going to say our ref angle is the inverse of cos of positive 1 over root 2, which we know is 45 degrees. And so therefore A will be the second quadrant angle that is partners with 45. And we find that by saying 180 minus 45, which is equal to 135 degrees. Right? I must say, corrected 1 decimal place is giving me heebie-jeebies. Yeah, it's not looking good. EAD. It's really not giving obtuse angle. If I look at this angle, I know we're not meant to swear by the diagram, but this angle is not really looking obtuse. So I'm just going to double check my workings. Okay, so we found EA by saying 5 minus 4 squared plus 4 minus 1 squared. So this is 1, this is 9, so that's square root of 10. Cool. AD is, we're going to say 8 minus 4 squared, 3 minus 1 squared. Okay, so that's 16. This is 4, so then we end up with the square root of 20. Right. Then lastly, for ED, we have 8 minus 5 squared and 3 minus 4 squared. So that ends up being 9. This ends up being 1. So we end up with root 10. Okay. And then the cosine formula tells us that, well, okay, and then we labeled our sides. So EA is D, ED is A, and AD is E. Okay, right, EAD. Right, so cosine formula tells us A squared is equal to D squared plus E squared minus 2DE cos A, which is the angle we want. Then we rearranged, so minus these guys, and then divided by negative 2DE on both sides. So then we ended up with positive D squared, positive E squared minus A squared divided by 2DE. It gives us cos of A. Okay, then we subbed in our values. So this is root 10 plus root 20 squared, root 10 also squared, minus root 10 squared. Okay, divided by negative, oh, it's not negative anymore. Oh my goodness, where did I get the negative? Ay, chakaramba. Okay, right. Okay, so yeah, well, we got a free lesson about ref angles and all of that stuff. Okay, so we are looking for okay, so it's also why it's so important to just where you can just like be a sounding board for yourself. Okay, so we're dealing with cos of A being a positive number. So where does that happen? That happens in this quadrant and this quadrant. And because we are in the context of a triangle, that means we're considering angles that are here or here. Okay, so this one does not make sense for our context. So we will only consider the first quadrant angle. So A will be the inverse of cos of 1 over root 2, which we know is 45 degrees. Okay, yes, do we agree? We do agree. Hooray. Okay, so they seem to have done a whole lot of angle of inclination stuff. Let's see. I'm just gonna rub this out because, yeah, you can rewind the video if you want to see what was going on there. So I'm guessing that why am I struggling? Let me just look at what they do. So they say the gradient of AD is a half. Yes. Then they find, so they extend this line to over here, and they find that angle of inclination. Right. And then from there, they find the gradient of AC. Well, they know the gradient of AC. We know that from the first question, I think. And then they find that angle of inclination. So if we extend this line, we can then find this angle of inclination. Okay, interesting. And then they say EAD will be the one minus the other. How do we get there, yo? So I mean, I can see that this is an external angle to this triangle, exterior angle. Okay, don't know why that turned into an arrow. So that would mean this angle plus this angle gives me that angle. Oh no, I think I'm going about this the wrong way. I'm not getting to the point that they were getting to. So let's not think about that angle. Yeah, I'm not sure. I'm not sure why EAD is this angle minus this angle. Oops. Okay, no, sorry, my bad. They did not, yeah, okay. I should have known there was a fish in the water when I said they worked out this gradient, when we actually did already work it out in the first part of the question. So they worked out this angle of inclination, then they worked out this gradient, and then they extended this line to then work out, okay, to then work out that angle over there, that angle of inclination, and then, okay, so that looks very tiny now. I don't know if there's a way that I can make it a bit bigger and clearer to see, but they worked out the gradient of AC, so then they could get this angle of inclination, and then they knew the gradient of that line, so they had this angle, right? And then using exterior angle, this triangle, right, they were able to say that this angle and that angle is equal to that angle, and then using vertically opposite angles, we know that this is equal to that. Okay, so that's pretty neat. Right, so that was another way to go about it for sure. So the third question says, hence or otherwise determine the area of parallelogram ADEF. Okay, so let's get rid of all of this. So we want the area of this parallelogram, okay, and we can get that, I think, using the area rule, because we've already worked out the length of EA and DE, for instance, and we have this angle, so then we can do the area rule. And if we can show that this triangle is congruent with this triangle, then by knowing the area of this one, we also know the area of this one. So let us show that first, actually. So what I want to do is to copy, maybe let's put it in a fresh, this picture. Oops. Forget the idiosyncrasies of this beloved application. Okay, so we have that triangle, and we want to show that it's congruent with that triangle. And to do that, we can say, we can do the side. So we know that, so we're going to say in triangle EDA and triangle EFA, we have EA is common. We have EF, well, okay, let's do the order, the triangle order that we chose in the first statement. So side ED is equal to side AF, and that is because opposite sides, space. Okay, I'm gonna write it big over here and then shrink it. So opposite sides of parallelogram are equal. Okay, so let me keep this down here. and duplicate it, just because we're going to use this reason again for the last. Right. So then, and then also the side, so that's these two sides sorted. Wait, what did I say? Oops, nope, it's not those two sides. So rusty. Okay, so this sorts out ED and AF. Okay, so now we need to talk about these two sides. Right, so we know that EF is equal to AD, and that is also because the opposite sides of a parallelogram are equal in length. Okay, and so what does that tell us? That tells us that triangle EDA is congruent to triangle. Okay, now we need to match up the angles. So this angle is equal to this angle. No, it's not. Yes, it is. Yes, it is. Sorry. Yes, it is, because these two will be co-interior angles, and these two are also co-interior angles. So it makes sense that these two are equal, right? So those two are equal, and then this one is equal to that one because of alternate angles, right? And then that leaves us with these two also being equal. Okay, so angle E in the purple triangle is equal to angle A in the blue triangle. And then angle D in the purple triangle is equal to angle F in the blue triangle. And then angle A in the purple triangle is equal to angle E in the blue triangle. Okay, so side, side, side. Okay, and then we can just sanity check. So that means side ED, side ED should be equal to side AF, right? And ED is equal to AF, good. And then side DA should be equal to side FE. DA is equal to FE, yes. Okay, and then lastly, EA should be equal to EA, yes. That's the common side. Okay, cool. Right. So we've proven that they're congruent, which means we just have to find the area of one of them. So let's do that. So area of triangle EDA is going to be half of this side times this side, which we found over here. So EA is root 10 and AD is root 20. So that is root 10 times, root 20 sine of A, which we found to be 45 degrees. And we can work this out by hand, I think. So that'll be half of root 200. And this is the same as 1 over root 2. And this is root, so let's actually simplify it, see what that yields for us. So this is root 2 times 100. And down here we'll have 2 root 2, which is root 2 times root 100. Down here we have root 2 times 2. Okay, so those are going to cancel out. And this becomes 10. So then our result is 5. So the area of triangle EDA will be 5 square units. So therefore, the area of the parallelogram FEDA will be, maybe let's just add another step of reasoning. So the area of triangle AFE will be equal to the area of triangle EDA, because of the congruency between these triangles. So because triangle EDA and triangle AFE are congruent, right? And so therefore it is also equal to 5 square units. And so the area of the parallelogram will just be the two of these added together, so 10 square units. Okay, right. What does the memo think? The memo is in complete agreement, and they also use the area rule. So so they don't go the whole route of proving that the two triangles are congruent. They just have a reason that says diagonal of parallelogram bisects area. I don't know, man. I never learned that rule when I was a kid. But yeah, maybe that's a reason you can use instead. Not maybe, clearly there's a reason you can use instead of first going through the pains of showing that these two triangles are identical. And yeah, that concludes question 2.